All right, we're going to look at a few definitions here. I'm actually going to start with subspace. So we could say that we've got some vector space W is a subspace of vector space V if, and we've got two conditions we need to satisfy. So the first condition is that for vectors U and V that are in W, U plus V is also an element of W. So closed under addition, and for some constant and some vector in W, then the scalar multiple is also an element of W. So we've got to be closed under addition and closed under scalar multiplication to be a subspace. All right, now let's look at linear combinations. Linear combinations are exactly what they sound like and what you might imagine. So if we've got some vector W, that's an element of our vector space V, then we can say that W is a linear combination of the vectors in V, linear combination of V1, V2, V3, etc., which are all elements of V, if we can write W as some constant times V1, a constant times V2, etc. We could have KR, VR. So if we can make W by adding up different vectors in V, then it's a linear combination. So now the spanning set. If we think of a subspace of V, so we've got some subspace here. So if we've got some subspace that is formed from all the linear combinations in some set of vectors, we would call that the span. So this is what we have for a spanning set. So let's write this down. So we've got subspace of a vector space V formed from all linear combinations in a non-empty set S. So let's say that S is equal to some of the vectors in our subspace. So W1, W2, WR. So we would say that S spans, so our span is all of these vectors W1, W2, etc. Your book would say, let's put an equal sign here, they would say LIN for linear combinations, W1, W2, etc. So basically we're saying that all of these vectors, these are the least number of vectors I need to form linear combinations to get all of the vectors for my set. So let's think about some of this. So if we say that we have the linear span of vectors 0, 1 and 1, 0. So these vectors span the vector space of real numbers in R2. Yeah, so any linear combinations of these, we would end up with R2. So we could say that these span R2. Yeah? So we're going to look at some examples of span and linear combinations and subspaces in our next examples.